In this video on how to construct the SumoBot, I want to give you an introduction to our SumoBot project. We start our project with the first SumoBot shown on the left, and we use 3mm standard LEDs. Then we do an upgrade to our SumoBot and we install the blue surface mount LEDs shown on the right. And then we upgrade our SumoBot with a new chassis and a track set, as shown on the right. So today what I want to do is introduce you to our three versions of the SumoBot. So this is our standard SumoBot. You'll notice that there's a large IC on the top. That is a PIC microcontroller, and that is the brains of the SumoBot. The smaller IC is actually a motor controller. On the top we have an infrared LED and an infrared sensor. So the idea being the infrared beam goes out and gets bounced back off of an object. So we're hoping the object's going to be the other SumoBot in the ring. When we take a look at the side view, we can see we have a lower infrared sensor, and that's a reflective sensor, so that detects the white band around the SumoBot ring. So this is a standard SumoBot ring, and you'll notice it's black with a white band around the outer edge. So the idea is to put two SumoBots in a ring back to back, start them up, and they will move off, detect the outer edge, and then come back and try and push each other out of the ring. Our first SumoBot upgrade is to insert a surface mount set of LEDs. So the original LEDs were actually in red. Our upgrade LEDs are in blue. Our second upgrade to the project is to mount our SumoBot controller board onto a track set. And you'll notice underneath we have to mount our bottom sensors so that the track set won't run the SumoBot out of the ring. So this is the SumoBot kit package that you're going to be getting. So in your kit you're going to get a Tamiya gear set, and I've prepared a separate video on how to assemble this. So in your kit you're going to get a piece of aluminum, and this is what we're going to bend to make the chassis, and you get a smaller piece of aluminum that we use to bend into the battery containment bracket. Both of these are contained in a separate video that will show you how to cut it out and bend it into shape. So in your kit you're going to get a booklet of instructions, and there's many pages to it. So the first page contains a picture of the project that we're going to build and a complete parts kit that we need to go over and check and make sure that we do have those parts in our parts kit. Also on that first page we get a part layout. So this is the part layout, and it tells you the reference number for each of the components and where they go. I've also given you the board layout, so you can look underneath the board and check all your traces and make sure that they are there and none that are missing. I give you the complete schematic of the SumoBot that we're going to be building. I give you a page of assembly instructions, so it's broken down into Part A, mechanical assembly. Further down you can see there's Part B, electronic assembly. And then we have final assembly. And the final step is testing. So this tells you how to adjust your potentiometers and sensors so that your SumoBot will work. I give you all the dimensions for cutting out the chassis for the SumoBot, and at the bottom I tell you all the angles you need. So like I said, this is covered in a separate video. And when it comes time to make your track chassis, I have a separate layout for it. So in your kit you will get the wheels and the tires for that gear set, and you're also going to get the printed circuit board. Now the printed circuit board is basically a piece of fiberglass with copper traces on it. You'll notice none of the holes are drilled for you, so this is not like a piece of perf board. And because the board's been sitting around for a while, it's probably oxidized, so you're going to have to go over it with a piece of steel wool. So I have a separate video on how to set up your board as far as cleaning it and getting it ready for tinning it, drilling it, and mounting some of the components. So one of the first things you should do is spread out all your components so that you can easily identify them. So by now you should know your resistor color codes, so I'm not going to go over them with you, other than to say usually if they're the same value, they're usually going to be together in a strip, though sometimes these two are the same value but they're loose. So it all depends on what we get in when we order them. These are obviously the 9-volt battery clips, and over here we have 4 wires to go to your motors. Here we have your main IC PIC chip, the PIC 16F877A. We have the socket for it. We have the motor controller chip, which is labeled L293D, and its socket. We have 2 potentiometers, and you should know how to read the size by now. I believe one is a 1K pot, and it should be labeled 102, and the other pot is a 10K pot, so it should be labeled 103. So make sure you don't mix those up when you put them in. We have a small push button. We've used these before. We have a dip switch. So this is a 2-position dip switch. And here we have a 4 megahertz crystal. This is heat shrink tubing, and this is standard tubing. So the standard tubing is used for standoffs. The heat shrink tubing will go around our infrared LEDs. So these are standard LEDs. They're actually the smaller ones. They're the 3mm LEDs, and we can actually see light coming from them. These two are the infrared LEDs. Sometimes they come in a purple color or a blue color or even a green color. Those are infrared LEDs, and when they're on you'll not be able to see them. These are your infrared detectors. So each of these components has a part number. So this is an infrared receiver, and its part number is GP1UD26XK. Over here we have our lower sensors, and the lower sensors are the QRD1114 sensors. So we have 2 of those. Hopefully you recognize this as a little transistor, and it's a 2N3904. We have 4 large mounting nuts and bolts, and I always put the nut on the end when I do the kits, because some students tell me it's stripped, it doesn't work, but if I put the nut on, then I know that every kit is okay. We also have 2 other nuts and bolts, and these 2 are to hold the battery containment strap in. This guy here is a LM7805, so we should recognize that as a 5-volt voltage regulator. We have several capacitors, so the ones that are in cans are going to be your 47 microfarads. These little tiny ones are your 15 picofarad capacitors, and in this case they're labeled 150 or 15 pico. We also have our 10 nanofarad capacitor. It's not always going to be this color, but it will be labeled 103. And we have another small capacitor here, and it will have its value stamped on it. So I believe this is the 104. So that's 100 nanofarads. We also have these connectors here, and what they are is they have screw terminals at one end, and basically you put your wire in them and screw the terminal down to hold the wire. So that's for your motor wires and your battery connector wires. Now they usually come loose like this, but you'll notice there's little tabs on them, and when you line the tabs up and slide them together, they form one complete block. So this last item that you have here is called a snappable header pin, and you notice it's bent at a 90-degree angle. It goes in the back of your SumoBot here, and what we use it for is to program your SumoBot. So what I do is I use a Picket 3 programmer, and one end goes into the USB port, and I can use it to program the IC. So this is the IC that we need to program, and when I put these kits together, I usually put a large white dot, and that to me indicates that the IC is already being programmed. So once the main IC has been programmed, you no longer need to put the programmer into your circuit. Now on the last bag of your kit, you get a small PC board, which you need to cut out, of course, and we get a large row of snappable headers so that you can actually connect this board to your main SumoBot board. This little package here are surface mount resistors. They're very, very small, and what you do is you take the plastic coating off, and then you can take out the individual resistors. So you might want to bring tweezers that day you decide to work on them. The same thing with the surface mount LEDs. They're in these little pods, so you actually have to take the plastic off of them to get all the little LEDs out. So I've already created a separate video on how to work with surface mount components. So in the last bag of your kit, we have the Tamiya track and wheel set. We have a large piece of aluminum to bend the chassis for the track set, and we have 2 small pieces of perf board. Now most students don't worry about this part of the project since it's only worth 5% of your grade. As with all my fabrication projects, we have the mandatory sign-off sheet for lab number 4, the SumoBot, and please make sure that you do get these sign-offs before you do the work. A lot of times students complete the whole project and then try and get the sign-offs. We need to be able to check your work as it's in progress. On the back of the sign-off sheet is the marking sheet, so you can see what you're going to be getting marks for or where you're going to lose marks, so that you can spend the appropriate time where necessary to get the maximum number of marks possible. For the SumoBot, it's marked out of a total of 30, so that's 30% of your grade. The SumoBot comes with 2 sign-off sheets. The second sheet is for SumoBot modifications. So the first modification is for the surface mount LED boards. The second modification is for the track set, and it's the chassis assembly modification. On the back of the sign-off sheet is the grading for the modifications. So Modification number 1, doing the surface mounts, is worth 5 marks, or 5% of your total grade. And then for the chassis, mounting the track set to it, that's another 5%. So the modifications are only worth 10% of your total grade.